Okay, then I would like to talk the usage of portable emission analyzers for emission compliance testing and diagnostics. You know, there are different sensor technologies used in flue gas analyzers. Doesn't matter if it's a portable system or if it's a stationary system. Yes, there's paramagnetic for oxygen measurements. There is infrared for CO, NO, SO2, CO2. This is basically TESTO uses infrared for the CO2 sensor. This is also important because especially at the cement plant you will have CO2 because of the fuel you're burning. You have a CO2 max, but this CO2 has been calculated in the past, which was okay if you don't have materials which absorb CO2 during the burning process. That means if you have a small burner and you would like to get the CO2 reading, you can use a calculation. But at a cement plant, it's different because during the process where the cement is being produced, a lot of additional CO2 of the material is being produced and emitted to the flue gas. And then you need to divide between the CO2 coming from the fuel and the CO2 coming from the material. And therefore, you have to measure the CO2 directly. Then we have also CLD, chemiluminescence, for NOx. This is basically an NO measurement, and they convert the NO2 back to NO, and then in sum you will get the NOx reading. Then we have gas chromatographs, mass spectrometers to measure all kinds of different gases. We have FID technology for measuring hydrocarbons in the very low range, but these techniques, doesn't matter if it's CLD, gas chromatographs, or FID, this is very expensive devices, and mostly they are not really, or they cannot be used in the field because of the rough conditions, like, they are sensitive against shock. You have to calibrate them all the time as soon as you change the location because there's different ambient conditions, like the temperature has changed, the pressure, the ambient pressure, the absolute pressure has changed. And those reference technologies, they have to be adjusted all the time if you change the location using such an analyzer. And then we have electrochemical sensors for all different parameters like oxygen, CO, NO, NO2, SO2, H2S, and some more. And we have Pelister for measuring hydrocarbons. This is also something we are using, Pelister technology, but this is a kind of cheap way to measure hydrocarbons, and it has its limits because with the Pelister you cannot measure hydrocarbons at a very low range. Our Pelister has its limits within, if you would like to measure below 1000 ppm, it doesn't make sense to use a Pelister because it's just the accuracy is plus minus 50% below 1000 ppm. Therefore, if you would like to measure, or if you have to measure hydrocarbons in a very low range, you have to use an FID, which is very expensive, but it fits to your application and you can fulfill the requirements, having an accurate hydrocarbon reading. So what is the benefit using a portable analyzer, using electrochemical technology? Compared to other instruments using reference technology, they are very easy, transportable, and relatively inexpensive compared to a reference analyzer. Here, we are talking about $10,000, $15,000, a full complete system. If you would like to measure the same with reference technology, it starts at $30,000, $40,000. We have long-term calibration stability. That means our recommendation is you can send in the analyzer once a year, where in the service department, the calibration is taking place. That means the sensors, if they are no more correct, they will be readjusted. And, or if required, you can also readjust or calibrate our analyzers in the field by yourself. That means if you have the different calibration gases with you, you can do the calibration by yourself without any problem. And it will be stored in the analyzer, and you can do a printout of the calibration date and the concentration and the drift and everything. Then you can measure NOx separately, like NO and NO2 directly is the most accurate reading because we have both parameters to be measured, and at the end we will build the sum of NO and NO2 to have the real NOx reading. They are accurate, the electrochemical sensors, between less than 2% and less to 5% after the calibration. That means even for a long-term stability, if you are within less than 5% over 1 year, that's a very stable reading. One advantage is they are field maintainable. That means with a simple on-site calibration and the possibility to change a pump or to clean a pump, or with our electrochemical sensors, they are pre-calibrated and they have all the calibration data on its circuit board. That means every sensor is pre-calibrated, and in case a sensor fails in the field during the measurement and you have a replaceable sensor with you, you can just remove the old sensor which is being used up, and you can put the new sensor inside of the instrument, and then you can continue the measurement without calibrating the analyzer with calibration gas. Yes, you have a complete multi-gas system in one box. That means you can measure up to, in our case, up to 6 parameters simultaneously, which is in some cases, if you are using reference technology, not possible. That means you have one analyzer measuring CO, you have one analyzer measuring NO, you have one analyzer measuring hydrocarbons, and with that kind of technology, electrochemical sensors, you have more parameters within one box, and you can, of course, cover many applications with one analyzer. Then broad operating ranges due to different sensor ranges. That means we provide a standard sensor for CO and NO, and we provide also a low concentration sensor for the very low concentration. This is especially a very big topic in Southern California in the US, because Southern California has very strict regulations regarding NOx, and all their gas engines, or especially low NOx gas turbines, within the next few years they are not allowed to emit more than 5 to 8 ppm NOx, and this is a very, very low reading, and we have to make sure that even such low readings can be measured with our instrument, not using reference technology and heated lines, because for the service technicians this is not really comfortable to use such sensible equipment in the field. And this is more and more coming also in Europe, that the NOx readings or the NOx limits will go down to less than 10 ppm. And the analyzer is accepted by state and federal EPA, at least in the US, and many countries follow the EPA regulations. And with our analyzers, we have done several tests, the ETV verification programs. That means that the EPA and the ETV, they used our analyzers in comparison with reference technology at different applications, like a gas engine, like a boiler, like a turbine with different fuels, and they compared the readings and they made sure, okay, our analyzer is as accurate as the reading of a reference technology, and they verified that this analyzer with electrochemical sensors can be used for those applications for compliance testing. One advantage of all portable analyzers using electrochemical sensors is rechargeable battery with outboard DC connection, AC operation. That means because the electrochemical sensors, they don't assume that much power, and this is why we can provide a rechargeable battery. And depending on your application or where you measure very high at the stack where no AC power is available, you can operate the analyzers up to 4.5 hours without any AC power supply. And this is in some applications a big advantage, or if you have a gas engine running in the desert somewhere where no power is available, you can also connect from the starter battery of this gas engine, or if there is a battery available, you can just put 2 wires to our analyzer and you can provide those 12 or 24 volts to our analyzer to operate in the field. Then gas-specific sensors target single parameters. That means with every sensor we can target a different parameter like O2 for the O2 reading, CO, NO, NO2, SO2, hydrocarbons. And then we have also an automatic sampling and conditioning system. That means with our TESTO 350, you can choose to have a gas preparation unit inside, which is a Peltier chiller to remove the condensate. And this makes sure that it doesn't matter at which day or in which location you are measuring, the gas conditions are always the same at norm conditions. That means the dew point is almost 4 degrees C, stable, and therefore you can compare the readings. Doesn't matter if there's a lot of humidity in the flue gas or if it's hot outside, because if you're just using a condensate trap without using a gas preparation unit, in many applications it works, but you cannot really compare different applications together. And therefore the gas preparation makes sure that the flue gas is being tried, and then you can compare the readings. Of course, thousands of analyzers in use, not only ours, also of our competitors all over the world. And this has proven that this technology has gained respect of technicians and regulatory officials alike. That means because not only we did comparison tests regarding to reference analyzers, also our competitors, and this was at a point the convincement for officials in all over the world to say, okay, let's change our regulatory from technology-based to performance-based, because you know, why shouldn't we allow an instrument which is less expensive, which has the same performance as a reference analyzer, but you know, a reference analyzer cannot always be used for every application, and also the companies cannot afford to buy a reference analyzer for their application, and this is why this took place, that they changed the regulations. And this is a specific thing of course, infrared technology and also electrochemical sensors, that they are really dependent on the temperature, the ambient temperature. That means if there is a increase or decrease in temperature, the sensors, they can start drifting. That's a natural thing of those sensors. But if you take care of this and if you know the characteristics of such a sensor, you can you can do a temperature control, and then you can get rid of this characteristic of the sensor. And all of our analyzers, they are temperature controlled. That means we measure the temperature inside depending of the sensor or within the sensor chamber, and then we do this compensation automatically. That means you don't have to worry about if the ambient temperature increases or decreases. It will be compensated automatically. And then, of course, I mentioned this before, the simple on-site sensor calibration capacity, including diagnostics and sensor output. That means even if you don't if you don't calibrate the sensors by yourself, we can do it for you in the service department. The advantage is because every electrochemical sensor is like has its lifetime between 2 and 5 years. And just to make sure that that you are not going out on site, do a measurement, and all of a sudden the sensor fails, with the calibration gas you can readjust the sensor, and then within the analyzer it calculates the remaining lifetime of the sensor in percentage. And this is a very nice feature, because if you put calibration gas on the sensor and it shows you, oh, there's only 70% or 50% left at a specific limit, like 30%, the analyzer tells you, okay, please be aware, have a replacement ready. It can fail within the next measurement or within the next weeks or months, depending on how often you will use the analyzer. That means if you calibrate the analyzer, you are on the safe side with the lifetime of the sensors, and you have a good overview when the sensors will be used up. Just one slide regarding the electrochemical sensor. What is an electrochemical sensor? Very basically, it's similar to a car battery. If it's cold outside, it's very slow. If it's hot, then the reaction within the sensor takes place very fast. Within this sensor, we have an electrolyte dependent on the parameter to be measured. That means O2 has a different electrolyte, O2, NO, whatever. All sensors have different electrolytes inside. Depending on the sensor type, there is 2 or 3 electrodes with an electrical field in between. And what happens is the flue gas, like O2, gets into the sensor through the membrane, and then here it will get to the cathode. And as soon it's in the sensor and in this electrical field, within this sensor, OH ions will be created, and they will immigrate to this anode. This is just a chemical reaction taking place, but depending on the O2 concentration in this case, the gas concentration is proportional to the move of the ionics to this anode. And when they immigrate to the anode, a little current will be produced proportional to this immigration, and all we do is just to measure the voltage at a resistant. And this is how you can measure O2. There's several different sensors available, but this is the way we do it. And the O2 sensor is very specific compared to toxic sensors like NO, SO2, whatever, because if you don't use the analyzer, the highest concentration, like 21% oxygen of the ambient air, will get through the sensor, and this is why the oxygen sensor normally will be used up as the first sensor if you buy the instrument, because if you don't use the sensor, the highest concentration will get through it and the reaction is taking place. And if you use the analyzer very often, there is just a few percentage, like between 2 and 8 or 10% oxygen, which helps a lot to expand the lifetime of the oxygen sensor. With the toxic sensor, like NO, SO2, CO, it's just a different way. And just one hint, if you're using an analyzer using electrochemical sensors, even if you don't measure very often, or if you don't use the analyzer very often, just to make sure every 4 weeks you switch on the analyzer and just to rinse it with fresh air to activate the sensors. Because if you don't use the sensors or the analyzer very often, the lifetime is still between 2 and 3 years, and then you have to replace the sensors, even if you don't use the instrument very often. This is something just for you to get the highest lifetime out of the analyzer and the sensors. If you don't use it, just switch it on after 4 weeks for a few minutes. Let the analyzer rinse and get fresh air through the sensors. Switch it off, and then you can expand the lifetime at least to 1/3. Okay. Then we have a specific function at our analyzers, the CO measuring range extension, which is called dilution system. This is very useful for out-of-control conditions, like at stationary engines or burners, or if you start, if you have to measure at a burner, which you don't know the conditions, then this functionality helps to protect the sensors. And it's basically the flue gas comes to the analyzer through the hose and the sampling probe, and all we do is to mix the flue gas with fresh air within a mixing chamber, and then the mixed flue gas, fresh air and flue gas gets to the sensors. And depending on the dilution factor, we can dilute from 2 times up to 40 times. It's freely selectable, the dilution factor. A valve will just put, according to the dilution factor, will put fresh air and flue gas together. And that means if you, for example, if you have 1,000 ppm CO and you choose 20 times dilution, the sensor won't see more than 50 ppm. And this helps to protect the sensor at high concentrations. And 1,000 ppm is not much, but if we are talking about 10,000 ppm or 20,000 ppm, what we recommend is to measure not that long, within a few minutes, and then to rinse with fresh air to protect the sensor. But if you're using the dilution system and you dilute with factor 20 or 40, the sensor gets only a very small concentration of the real CO, and therefore you can expand the measuring duration or the measurement time, and of course the lifetime of the sensor. And since we know which dilution factor you have chosen, you will get the actual reading. That means 10,000 ppm in the display of the analyzer. That means the sensor gets only a 50 or 100 ppm, but you will get the real CO concentration in your display. And this is also if you have, depending on if you have to do long-term tests, because some regulations, they say you have to measure for 1 hour, doesn't matter how high the concentration is. And if you can, if you calibrate the sensor and the dilution system, you will be within 5% of accuracy, and then you can expand the measuring duration up to 1 or 2 hours without destroying the sensor. And one thing as well, this has to be mentioned, because electrochemical sensors, they have cross sensitivities, they are well known, and depending on which sensor you are measuring or which gas you are measuring and which gases are in the flue gas, there can some cross sensitivities taking place, and the CO sensor is cross sensitive to H2, and this is very, H2 will be created if you have very few oxygen and very high CO readings. That means when lambda is less than 1. At these conditions, especially at gas engine, you can have very high H2 readings, and this can influence the accuracy of the CO reading. That means the cross sensitivity of H2 to the CO sensor is 60%. That means if you have, just a simple example, if you have 100 ppm H2 in the flue gas and the cross sensitivity is 60%, it's 60% of 100 ppm, the CO reading will be 60 ppm wrong additionally to your to your current CO reading. And some manufacturer of analyzers, they don't provide this cross sensitivity or this compensation of H2, but we thought, okay, in many applications it's necessary, because especially at these gas engines where you have high H2, your CO reading will be completely wrong if we don't compensate this. And this will be done automatically within the sensor, and therefore you can also choose H2 reading in your display. But you know, the H2 reading in your display is just an indicator. The accuracy is plus minus 50%. It's not very accurate, but it's as accurate for the compensation taking place. This is just also an information because we got a lot of requests. Okay, we have the H2 reading in the display. It's very high. Can this be? And usually the H2 reading should not be used as a parameter to be measured. It's just for the internal compensation. But you can show it. And then, because of this dilution system, no second sensor with higher measuring range is necessary. This is also, you know, our philosophy is to provide such a dilution system, and then you can use your specific sensor and you can extend the measuring range according to your dilution factor. And some competitors, they provide just, okay, we have a low range sensor and we have a mid range sensor and we have a high range sensor for CO, NO, and according to your application you have to choose the right sensor. But that means if you have two different applications where you have high readings or low readings, you have to have two sensors within the same instrument, which has an influence of the costs, of course. Okay, and this is just an example what could happen to the sensor. The orange line is with dilution system and the blue line is without dilution system. That means if you put high concentrations on the sensor, like in this example it was the CO sensor, for a long time, this was over 6 hours, 6 minutes, then it can happen if you switch the analyzer to fresh air. Because of this high concentration, it takes a while till the sensor gets down to 0. That means you have to rinse and rinse and rinse the analyzer just to make sure that the CO concentration gets out of the sensor. And because of the dilution system, you will get the high reading as well. But since the sensor does get only the very low concentration, it's very fast to get to 0 again. And this is important if you do, if you do a long-term test over a few hours or days, and then you can program a measurement, like I need to measure for half an hour and I would like to rinse for 10 minutes, and this is for the next 2 days. And if you're not careful, or if high concentrations occur during the measurement, this is very typical that the sensor starts drifting. That means if you don't make sure the sensor gets to its limits, then you can have a wrong reading after a while. And mostly you recognize this when the measurement is being done, and then you have a look to the numbers or to the measurement dates, and then you figure out, okay, the CO reading is wrong because I had a peak of 10 minutes with high concentrations, and then the whole reading is gone and you have to perform the measurement. We are talking about the gas engine. It can be used for everything, like, yeah. Okay, then I would like to talk about gas extraction and gas conditioning. A very basic overview how our system looks like is we have our flue gas stack, our process gas, whatever. And then we have the sampling probe, which gets into the stack. In some cases, you need a pre-filter, like at cement plants, or if you measure at diesel engines, stationary engines, or where you have a high dust concentrations just to protect the analyzer. And then the flue gas goes to the gas cooling system to remove the condensate of the flue gas. This can be an external device, or this can be an internal integrated system like a Peltier chiller, a small one. Then we have the sample lines between the flue gas probe, the chiller and the analyzer. Those lines can be heated up if necessary, or they can just be a regular line or a Teflon line. And then we have the analyzer with internal filters just to protect the sensors, not to get any soot or particulate to the membrane to stop them working. This is basically how a system looks like. And TESTO is providing different flue gas probes for different applications. We have heated and unheated sampling probes. Like this is an industrial probe with a heated handle, a heated pipe. Sometimes necessary, you know, if the wall of a stack is very thick and you have to make sure that your SO2 reading or NO2 reading has to be very accurate, because, you know, SO2 and NO2, specifically those two gases, they react with the condensate in the flue gas very fast. That means if you have condensate here within the probe and the flue gas passes through, it could be that NO2 or SO2 gets absorbed. And the result is, at the end, if the flue gas passes the sensors, you won't have any NO2 or SO2 at the sensors anymore, because it got absorbed within the whole sampling system. And this is why you have to make sure that the temperature of your sampling system is above the dew point. In some applications, it's required to have such sampling systems. Then we have different probe materials, like, you know, our probes can be used for small temperatures like 500 degrees C, or they can be used up to 1800 degrees C, depending on the material you're using. And then we have probes with sintered or ceramic filters, and also the probe length is different depending on the diameter of your stack. And then we provide also pitot tubes to measure velocity, flue gas velocity within the stack, to calculate volume flow or mass flow. In the past, as we developed our flue gas analyzers, we figured out, depending on the regulatory in different countries, that heated lines are required and necessary just to prevent the absorption of NO2 and SO2 during the measurement. And then, after talking to some customers and being on site and performing measurements, we figured out that heated lines are very sensitive. You have to make sure that there is no break between the heating wires, and yes, they are not easy to handle, and you have to have AC power on your side, on your measurement sampling point. And this is why we started thinking of how to prevent this and how to get a new solution. And basically what we did is we developed a special PTFE hose, which is similar to Teflon, and we patented this hose. And the feature of this hose is, because we have a very small diameter of the inner hose, which is 2 millimeters, and because of this small diameter, we get a very high flow of velocity within the sampling hose. And even if we have condensate and flue gas here inside, we don't give the flue gas and the condensate the chance to react together, because of this high flue gas flow or volume flow. There is no chance for the condensate to react with NO2 and SO2. And this is why our readings with our PTFE hose is almost as accurate as using a heated system. And of course, the advantage is you don't need to have AC power on site. The hose is very rugged. You don't have to take care of, you can almost do everything with the hose. And for service technicians, it's very convenient to do a fast measurement or a long-term measurement, turbines, engines, whatever. So this is one big advantage. And here you can see, of course, as we developed this, we did several comparison tests with the most critical gases like SO2 and NO2. And here you can see the pink line is with heated hose, and the blue line is our Teflon hose with 2 millimeters, not heated. And you can see the reading is as accurate as with the heated hose. Maybe there is a less than 2% difference. But another thing, because of our high gas flow, the high velocity inside, the reading is very fast, faster than using a heated hose. This is in some applications also a big advantage if your reaction time or your response time is very fast. And here, especially NO2, you can see the difference. There is a few seconds delay compared the heated hose with our Teflon hose.